Welcome to the migration. As these cranes fly a steady path over the wetland, we can track their progress, measuring distance over time. This graph plots their flight. The y-axis, takeoff point, represents their starting roost. The slope represents the flock's steady speed. But not all flocks are tracked the same way. We represent these flight paths using different mathematical tools: graphs, data tables, and equations. Every function follows the same rule: one input, one output. Comparing these different representations side by side builds flexibility to read variables and understand exactly how they interact. To find the greater rate of change, compare function A's table and function B's equation. In the table, y values increase by 4 and x values jump by 2. Dividing them yields a rate of 2. In the equation, the x coefficient reveals a rate of 3. 3 is greater than 2, so function B has the greater rate of change. Extracting properties from distinct formats allows for direct comparison. Next, we compare initial values of function A's graph and function B's table to see which flock starts higher. On function A's graph, the line crosses the y-axis at 5. In function B's table, finding where x is 0 reveals a starting y value of 2. 5 is greater than 2, so function A starts higher. Finding the baseline intercept accurately is the required first step for these comparisons. Finally, compare outputs when x equals 4. In function A's equation, substitute 4 for x. 2 times 4 plus 7 yields 15. On function B's graph, finding 4 on the x-axis and tracking straight up to the line gives a y value of 10. Comparing the two, 15 is greater than 10, so function A has the greater output. Evaluating specific intervals is just as important as overall shape. You have successfully tracked the migration using tables, graphs, and equations interchangeably. When communicating your findings, use this simple structure. Function A's rate or value is blank. Function B's is blank. Extracting these properties from various visual formats builds directly upon the foundational definition of what a function actually is: one input yielding one precise output. Mastering this cross-format flexibility equips you to confidently model, analyze, and predict outcomes in more complex real-world systems.